an eye on what I copy. Sometimes I copy from two different problems. So f prime of 0 is 0. F double prime of 0 is less than 0. At 0 is less than 0. F of 0 is 5. F prime of 2 is 0. F double prime of 2 is positive. F of 2 is 2. F prime of 4 is 0. F double prime of 4 is less than 0. And F of 4 is 3. Who can understand this language? I don't think anyone can. That's nothing. I have no idea what this means. But we will very, very shortly. The reason why we put, you can create your own order, of course, but the reason why I put the function in the middle is for the following reason. You can rearrange them as you like, but here's the reason why. Because the values are in the middle and I can read up and down. So if I put this first, it will be slightly more difficult to look at those two lines. So that's why I put the function in the middle and I look up and down, meaning positive, increasing, opening down, decreasing, still opening down, decreasing, but opening up. And I have in the middle all these points. You can create your own order. That's fine if you prefer a different one. If it works for you, it works for me. Okay, so we're going to make sense of all this. So I'm going to cross them out as they find their way to the table. F of 0 is 5. Careful. F of 0 is 5. F of 2 is 2. F of 4 is 3. F prime of 0 is 0, which means this is a critical number. And the value or the pair is 0, 5. We'll see what this is. F prime of 2 is 0. This is another critical number. F prime of 4 is 0. That's another critical number. Now, the second derivative at 0, is positive, which means the function holds water. What type of point is 0, 5?
Relative maximum.
Very good. Careful.
Relative minimum.
Yep. F double prime at 2 is positive. What type of point is 2, 2? Ah! See, I copied something else. It says negative, and I copied positive. That's why I heard relative maximum, and that was correct. But I copied positive. Sorry. Sorry about that. Absolutely correct. Because it says negative. I wrote positive. Thank you. So the second derivative 2 is positive. What type of point is 2, 2? What type of point is 2, 2?
Minimum?
Yes, relative minimum. Very good. That is true. Thank you. The second derivative at 4 is less than 0. What type of point is 4, 3?
maximum.
Yes, relative max. That's it. The whole thing now is extremely clear. So when I graph an example, there are many different correct answers. So 0, 5, 2, 2, 4, 3. I know exactly how to graph this. This has to be a relative max. This has to be a relative min. This has to be a relative max. Relative max, relative min, relative max. This is my example of f of x. Very good pick. Thank you. Okay, so are we going to look at a word problem next, or we want to choose another graph?
Can we do a word problem?
Yes. Good. So let's take a look at the word problem. The Gotta Have It device is introduced in a market with 150 million potential buyers. The unit sales are modeled by the function S, given by. Is this a good one? Is that okay? I'm on page 3. So S of x, so this is 41, equals negative 0.0131 x to the third plus 0.661 x squared minus 2.021 x plus 6.865. It takes us 5 minutes to put this function in the calculator, and it takes us and read the problem, and it takes us 1 minute to solve it. S is the total in sales, millions of units, okay, millions. Good. And x months. Find the point of inflection and interpret its meaning in terms of the rate of change in sales. We don't have to graph. The numbers are, I'm not saying it's difficult. We'll see. If we want to graph, we can graph. I don't like to just go to the graphing calculator and say graph it with the calculator. I like to do the whole analysis because that's what we are studying here. So, we're asked to find the points of inflection, if they exist. So, what is the first step? Anyone would like to tell us what to do first? It's okay if you're wrong. Give it a shot.
Take the derivative of s of x.
Yes, we have to find the first derivative first. Yes, s prime of x, negative. I multiply 0.0393 x squared plus, multiply by 2. 213. So let's say 123, 123. X minus 2.021. Awesome. So we found the first derivative. Now what? What is the next step? What do I need to do next? I have the first derivative.
Would it be plug in 150 million?
Careful, careful. So let's go back to the problem. Let me share my screen. Here it is. Find the point of inflection and interpret its meaning in terms of the rate of change in sales. We have the first derivative. Now what?
We have to find a second derivative.
Of course. We're not at inflection points yet. Excellent. Who was that?
Cecilia.
Thank you. So 6, 8, 6, 7. Do I have 4? I have 4. Plus 1.322. Awesome. Now what? What is the next step? In order to find the points of inflection or point of inflection, what do I need to do next? How do we find the points of inflection? There is no such thing. This is a polynomial function. It cannot be undefined. It's the same thing with the critical numbers, the same idea, same steps. So when I say this equal to 0, and I get 1.322 divided by 0.0786. And I have a calculator. 1.322 divided by 0.0786. I'm trying to see if I entered everything correctly. 16.82. So I got x equals 16.82. And this is months. Good. So the inflection point, so this is x, and this is 0, and this is 16.82, and this is s prime, and this is s, and this is the second derivative, and it's 0. How do I find the point of inflection? What do I have to do? Because this is just x value. I need the point. The inflection point has 16.82. What? How do I determine the y value? What do I have
Plug
to?
in that number.
Yes. In which of these three functions? I know it's silly, but I just want to hear it. This has nothing to do with the concavity. This I know it's 0. So the only one that I can plug in is,
The original equation.
of course, in the function itself. Good. So I'm going to share my screen. Get the function in here. Go to y equals, clear everything, and put in our function. Negative point, as I said, it will take me a minute or 2 or 3 to put the function in. Okay. And then plus 0.661 x squared, and then minus 2.021 x, and finally plus 6.865. And now, second and table, we want 16.82. Okay, go and highlight, and remember this is S in millions. So 97.54. So 97.54 million. Okay. Now, let's study the sign of the second derivative. So the second derivative is this. I know it's 0 at 16.82. Plug in a number to the left, like for example 0, and tell me the sign. Don't calculate anything. I don't need a number, I just need the sign. When you plug in 0. That's it. On the other side, let's say we plug in 100. 100 will be negative 7. Careful, with 100.
Negative?
Yes. Yes, it's a linear function. If it's positive here, it's negative here. If it's negative here, it has to be positive here because it's linear. It's a linear function. Good. So we determined the inflection point, 16.82, 97.54 million. 16.82 months, 97.54 million. We determined that. Now, notice what happens. So the function here opens, oops, let me use a different color. The function, where's my red? Okay, here it is. So the function here opens upward, and the function here opens downward. So opens up to the inflection point, and then opens down. So we are asked, let me share my screen one more time to see the problem, the question. We are asked, find the point of inflection. Done. Interpret its meaning in terms of the rate of change in sales. So notice what happens. This is the function. This is S of x. Opening up till the point of inflection and then opening down. And as we mentioned a few minutes ago, the rate of change, 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 the rate of change. I'm graphing slopes. I'm not slopes. I'm graphing tangent lines. So the rate of change increases, decreases, decreases. So see here, it starts with a huge negative rate of change, smaller negative rate of change, smaller, zero, positive, bigger. Oh, okay. Oh, well, positive but smaller, smaller, zero, negative slope, bigger negative. So the sales before the inflection point, the rate of change of the sales is positive, bigger. But then it starts becoming smaller and smaller. Rate of change, smaller rate of change. Okay. Final question, do we look at another graph or we continue?
Can we look at another program?
Okay. Would you like me to choose or would you like to choose?
You can choose, please.
I would like to choose 15. Slightly different. This is not a polynomial function. Still very friendly. I'm on page 4. So we have 15. So f of x equals x e to 3x. Say it again.
Oh, I was gonna ask you if you would consider number 26 friendly or not.
Let me take a look.
Okay.
26. This one?
Yes, ma'am.
Yes.
Yes,
Excellent. So it's a perfect question, but it's coming up in the next section. So let me, no. It's a very good question. We have a full section about rational functions. So I will show you quickly on page 305. That's our next step. So
because I
when,
was looking at it, it just looks complicated.
sure, rational functions, where's why? Okay, so we're going to go to 305 next. And you're going to see the entire section is all about rational functions. See? Everything. Here, the entire section 3.3 is all about rational functions. And some other functions, but a lot of rational functions. Okay. So back to our function, x e to 3x. Not a friendly function per se to work with. Friendly because the domain is all real numbers. As we know, this is defined everywhere. This is no problem. So f prime of x, f of x and the second derivative. Good. So all real numbers. Now, we have to first start with the function. We have to exhaust the function. What does that mean, exhaust the function? Oh, let me